Okay, so this is the week 7 of General Physics 2. So in week 7, we have here the most essential learning competencies. At the end of this module, you, the students, must be able to define magnetic flux, solve problems involving magnetic flux, and cite practical applications of magnetic flux in our daily life. So those are the different learning competencies that you're going to attain after the session. But before we proceed to know what is magnetic flux or solve problems involving this magnetic flux, may I ask you, do you know your cousins? Do you know who are your cousins? Julius? Do you know your cousins?
One, ma'am.
Okay, so you know your cousins. Therefore, you also know the names of your cousins. Yes? So, in this part, let's relate cousins, or let us know who is the cousin or what is the cousin of electricity. Any idea what is the cousin of electricity? JL, do you know the cousin of electricity? Shahani, what do you think is the cousin of the electricity? Okay, so the cousin of electricity is magnetism. So, magnetism is the first cousin of electricity. Take note of that one. When you say magnetism, it is a way of finding stone, or it has the ability of lodestone to attract iron. So, attraction. In this portion, when we talk about lodestone, this one lodestone, it is a way of finding stone, or one side of a lodestone always points south and north. So, simply, pag sinabi nating lodestone, it's simply like your magnets. When this lodestone has north and south poles. Okay? That's why the lodestone is also made as the first compass used by the Chinese in 11th century. So, that is the use of lodestone or magnet. Okay? Can you give me examples? Examples of appliances at home that uses magnets? Can you give me examples of appliances at home that uses magnets? Anyone? Ano ba yung mga example ng appliances na gumagamit ng magnet? Or would you cite? Yes, John Lloyd?
Radyo, ma'am.
Radio, okay, very good. Radio. What else? Ref, okay, very good. Ref. Ano pa? Yung mga appliances or materials at home na may magnet. Ref, radio. Ano yun, Julius? Oh, electric fan. Very good, Shahani. Electric fan. Okay, so there are many appliances that uses magnets, especially at home. And I have here also some examples. Ito sila, refrigerator, memo holder, loudspeakers, ovens, electric fan, TV, radio. So, meaning magnets are very important in our daily life livings. So, meron mga gamit ang magnets. But, we have here two classifications of magnet. Ano kaya yung two classification niya? We have here, first is the natural, and the second one is the artificial. When we say natural, it is found in the nature. So, examples are lodestones or magnetites. So, example of this one, magnetites, amo yo dayjay black nga magmagnet yo. We call that one as magnetite. The natural the color black. So, magnetic substance, one that is attracted by a magnet and can therefore be magnetized. So, that is magnetic substances. Meron din naman tayong tinatawag na non-magnetic. Pag sinabi naman natin non-magnetic, these are woods, paper, glass. So, those are non-magnetic. Pero pag sinabi nating magnetic substances, those that can be attracted by magnet. So, that is natural magnets. Next is, we also have your artificial magnet. Artificial magnet naman, magnetic substances that are used by man makes artificial magnet. Or, magnetic substances that are made by man artificially are called artificial magnet. Examples are iron, steel, and cobalt. Another one, artificial magnets is classified into two. We have here temporary and permanent magnet. So we have here temporary, example is the pure iron, then permanent, example is the steel. Bakit kaya may temporary at permanent? Pag sinabi nating permanent, pag dinikit mo na siya, mahirap na siyang matanggal. Pag temporary, pag dinikit mo siya, maikattumot lang. Or ikajaje mo lang, maikattumot lang. That is what we call temporary and permanent. Bakit kaya classify nila ito? That is because of the term retentivity. Pag sinabi nating retentivity, it is the ability of magnetic materials to retain magnetism after it has been magnetized. That's why it is classified as two, permanent and temporary. Next, we also have three most common shapes of artificial magnet. First is the bar, mostly used in school to study magnetic properties. So, yung bar natin, I think you already seen that one. We have here yung red dito, south, north and south. So, that one is a sample of bar magnet. Next, we also have here horseshoe. Horseshoe used in electronic and electrical equipment. So, pag horseshoe magnet, symbol niya para siyang horseshoe. Wherein we have here north and south. Okay? That is horseshoe. Sunod naman is we also have here the ring magnet. Ring magnet used in computers, memory cores, and speakers. So, yung ring magnet naman natin, circular lang siya. Okay? So, those are the three types of, or three common shapes of artificial magnet. Question. What magnet is used? What shape of magnet is commonly used in school? Okay, very good, Shahani. Please open your mics. Bar magnet. What about, it is most used in computer, memory cores, and speakers. What shape of magnet is used in computer, memory cores, and speakers?
Round.
Yes, Julius? Okay, ring magnet. Lastly, it is used in electronic and electrical equipments.
Horseshoe.
Okay, horseshoe. Very good, Very good, Julius. Adli also. So those are the three common shapes of magnets or artificial magnets. Next is we have this one, magnetic poles. So magnetic poles, gaya ng sabi ko kanita, magnetic poles, we have two poles. Those are the south and north pole. But who discovered that magnet has two poles, the south and the north pole? Sino kayang nakadiscover niyan? So it was discovered in 1269 by Pierre de Maricourt. So he is the one who discovered the two poles of magnet. Okay, that magnet has two poles, south and north pole. So that is Pierre de Maricourt. Next, sabi niya, magnetic poles that are alike repel each other. Example, north and north will repel, south and south will repel. And poles that are not alike with each other will attract. That's why they call this one as the law of attraction and law of repulsion. Okay? So yan si Pierre de Maricourt. Sunod, a man also discovered that magnetism appears to be concentrated at pole ends of the magnet. Meaning, the concentration of the magnets are in its ends. Dito sa dulo. Pag sinabi natin concentration of magnetism, the end portion of the magnet is ano ba yun? Mas malaki yung magnetism niya. Mas mabigat, parang ganon. That's why if both ends and ends put together, mas malakas yung pull niya kasi yung magnetism niya, it is concentrated at the end. Pero pag ganito, for example, pag ganito, mas mahina yung retentivity niya or mas mahina yung pull niya. Kasi nga, nasa dulo yung puwersa ng magnetism. That is only applicable if unlike charges, okay, pag north and south. Kasi pag south and south, the tendency they will be separated, they will be repelled with each other. So, sino kayang nakadiscover nito? It was discovered by Peter Peregrinus of France in 13th century. So, he is the one who discovered that magnetism appears to be concentrated at poles or at the end of the magnets. Next, we also have the types of magnetism. We also have types of magnetism. But before that, let's first know magnetic field. Pag sinabi nating magnetic field, region of space where magnets is capable of exerting a force on a magnetic material. So, as you can see, we have here the yellow one. The yellow one surrounds a magnet. We call that one as magnetic field. Okay, the magnetic force exerted in the region around the magnet is the magnetic field. This allows magnets to interact without touching. Okay, so yan yung gamit ng magnetic field. Allows the magnet to interact without touching it. So magnetic field lines is spread out from pole to pole, curve around the magnet, and return to the other pole. So curve around the magnet, then return to the other pole. So that is what we call magnetic field. Next, let's go now to the different types of magnetism. Oh no. Wait. types of magnetism. So as you can see, we have here pero, para, and dia. So, pero, this one is, ano ba yan? This one is ferromagnetism. So, ferromagnetism is the strongest or has the strongest attraction among all the three types of magnetism. Direction, same. Examples are iron, nickel, and cobalt. So, those are ferromagnetism. Next is we have paramagnetism. Paramagnetism, it is weaker than the ferromagnetism, or it is the second strongest among all the attraction. Same but not all. The direction are same but not all. Examples are palladium, platinum, actinides, and transition metals. Sunod is the diamagnetism. Diamagnetism is the weakest or has the weakest attraction among the three types of magnetism. Direction, it will repel. Next, example is water, organic compound, bismuth, copper, silver, gold, and non-metal. So those are examples of magnetism. Or those are types of magnetism. We have pero, para, and dia. Again, example. Which of the three types of magnetism is the strongest or has the strongest attraction?
Ferro.
Okay, very good. Ferro. Very good, Adlian Julius. Ferromagnetism. What about the direction of this magnetism is same but not all?
Para.
Okay, very good. Paramagnetism. Example of this magnetism is water. Okay, very good. Diamagnetism. Okay? So those are types of magnetism and magnetic fields. Now, we have here Michael Faraday in 1830s. Michael Faraday introduced the magnetic field as made of lines of forces. So, yan si Michael Faraday. And the number of lines here, made of lines of forces, okay, that is magnetic field. Take note, pag this one is the magnet, it is surrounded by a magnetic field. Okay? And, pag sinabi nating the number of lines, we call this one as your magnetic flux. Again, lines of forces that surrounds the magnet is called magnetic field. Okay? But the number of lines is called magnetic flux. Okay? So, the flux is measured in Tesla. Flux is measured in Tesla. Okay? Tesla or big letter T. So, yan si Tesla. Next, magnetic flux. Magnetic flux, in 1820s, Hans Christian Ørsted discovered that a current carrying conductor produces a magnetic field. Michael Faraday carried out experiments to prove that the reverse of what Ørsted discovered was true, and concluded that magnets can produce electricity. So, yan naman yung sinabi ni Michael Faraday. And they were able to determine or define what is magnetic flux. Please read, John Lloyd.
Magnetic flux. The magnetic flux through a surface is defined as the number of magnetic passing through a given closed surface. It provides the measurement of the total magnetic field that passes through a given surface area. Here, the area configuration can be of any size and under any orientation with respect to the direction of the magnetic field.
Okay, so they were able to determine what is, thank you JL, what is magnetic flux. And dito sa magnetic flux, the unit for magnetic flux was then discovered by Tesla. Sino ba si Tesla? Tesla, the name of Tesla is Nikola Tesla. Sino kaya si Tesla? Nikola Tesla has more contributions in the field of technology rather than Michael Faraday. Bakit kaya? That is because si Tesla, he was considered as the father of technology sana. Pero, iba yung title na niya. He was the father or the forgotten father of technology. So, meaning, most of the works of Tesla was then credited into someone. Kaya siya tinawag na forgotten father. Forgotten father of technology. So, yan si Nikola Tesla. Okay? So, magnetic flux formula is given by, we have here, this one is, the magnetic flux is equal to BA or BA cosine theta. When these symbols, this one is magnetic flux, or simply we will be using this one, I tapos may circle sa gitna. That is magnetic flux. Then, B is the magnetic field. Then we have here A. The A is the area. And the angle is in degree. So, angle at which the field lines pass through the given surface. So, those are samples of this one. Next, magnetic flux. This one, magnetic flux symbols or units. Magnetic flux is usually measured in flux meter. The SI and G standard unit of magnetic flux is given below. So, magnetic flux, we will be using Weber. Then, we have here volt, seconds, or Maxwell. Okay? But in this portion, the magnetic flux, we will be using Weber. Okay? Weber yung gagamitin natin. WB. Let's have an example. Please read example number 1, Adli.
A loop of wire is placed in a magnetic field of a uniform strength of 3.0 Tesla that is parallel to the normal of the loop. If the magnetic flux is 9.09 Web, what is the area of the loop?
Okay, so what is the area of the loop? Let's proceed to the computation. Okay, so we have here example number 1. A loop of wire is placed in magnetic field. Sabi niya ganyan. So, first, let's determine the given. Ano ba yung mga given natin? Take note, we have here B. B is the magnetic field. The B here must be in Tesla. Okay, the unit is Tesla. We also have here magnetic flux. The symbol for magnetic flux is like that. The unit is in Weber. Then, we also have the angle. The angle. Okay? So, let's proceed. Ilan yung magnetic field natin? What is the value for magnetic field? The value for magnetic field is in order for you to see what is in the slide, please i-landscape you guys para mas malaki. I-landscape you. Okay, so what is the magnetic field? Please open your mic. This is recorded so that
0.
okay, we have there 3.0 Tesla. What about the magnetic flux?
0.91.
Okay, very good. 0.9. Then what about the angle? May angle ba tayo? Is there an angle? Okay, let's try to look on the given. A loop of wire is placed in magnetic field uniform strength of 3 Tesla. That is parallel to the normal of the loop. If the magnetic flux is 0.9 Weber, what is the area of the loop? So our consideration in this problem to determine the angle is parallel to the normal of the loop. For example, this one is the loop. Sabi niya, parallel to the loop. Take a look of your protractor. What will be the angle if it is parallel to the loop? Nakaidda lang. It will be equal to ilan?
100.
Okay, hanggang 90 lang tayo hanggang 90 degrees lang tayo. It will be equal to what? Nakaida lang. Okay, in your protractor, we have here, ano ba yung nandito? 180, di ba? 180, ano ba yan? Nawala na yung, ano ko. Okay, in your protractor, okay, this one is your protractor, 0 at tapos dito 180, di ba? So sabi ko, dito lang tayo sa hanggang 90 degrees. It is parallel to the surface. What will be the angle pag parallel to the surface? It is equal to parallel to the surface. It is 0 o 180. Okay, so the answer is 0 degrees. Okay, 0 degrees. So, we completed already the given. Now, let's proceed to the unknown. Our unknown here is determine the area. So, we need to find the area. Okay? Next is the formula that we're going to use. Our formula, magnetic flux is equal to BA cosine theta. Okay? We need to find A. So, we divide both sides by B cosine theta, B cosine theta. So, cancel. So our main formula will be A. Our main formula will be A is equal to magnetic flux over B cosine theta. Okay, so that will be our formula. Next. Sunod, we substitute the values in our solution. So, A is equal to, yung I natin, 0.9 Weber divided by B, 3.0 but ayaw mag-point. 0.0 Tesla cosine 0 degrees. So, A is equal to ilan? A is equal to anyone? Yes, Adli, what is your answer? Open your mic, anak.
0.3 mo.
Okay, very good. So, 0.3 and the unit for area is meter square. So, we have here 0.3 meter square. So, that will be the answer. Okay? Next. You can take your screenshots. Next. Let's have here example number 2. Let's have example number 2. Ano ba yan? Ano ba kaya? Okay, example number 2. Please read example number 2. Okay, please read example number 2. Shahani. Shahani, please read example number 2. Wala si Shahani. Okay, so ay madit mic ni Shahani. So let's have Julius na lang. Julius.
A coil of wire is situated in a zero. The area of coil is 2.0 meters square. What is the magnetic flux if the magnetic and the normal force of the coil is 60 degrees? After 5 seconds, the magnetic field is parallel to the normal. Find the change in flux. Find the flux in joules.
Okay, so thank you, Julius. So that is example number 2, a coil of wire situated. Sabi niyan dyan. So, first, let's have the given. Ano ba yung given natin? Tesla, we have here Tesla. Tesla is the magnetic field. So, we have 0.5 Tesla. Then, we have here the area is 2.0 meter. Area is equal to 2.0 meter square. Next, we also have, ano pa yung nandyan? What is the magnetic flux if the angle of the magnetic field and the normal to the surface of the coil is equal to 60 degrees. So, meaning, the angle is 60 degrees. So, we are done with the given. Then, let's proceed to the unknown. 60 degrees. So, we have the unknown. So, for our unknown, yung una nating unknown is, what is the magnetic flux? So, that is the first unknown. Okay, let's put here A. Our unknown, letter A, is